Okay, so the next topic we're going to go over is bonding and electronegativity. So just to set this up, let's go over some old forms of bonding that you guys have probably seen before in general chem. So a couple of bonding types that you're probably used to seeing are ionic and covalent. The main difference between the two in terms of the mental model that we hold is that for ionic bonding, you have one atom which is essentially stealing electrons from another atom. And an example of that would be sodium chloride. So of the two, chlorine has effectively stolen the electrons from the sodium. Sodium has given its electrons to chlorine, completely lost them. For this particular molecule, HCl, when we draw bonds in this manner, what we're really saying is that the electrons haven't been stolen or lost. They're actually being shared. And so now, how do we even know when we should classify something as ionic and when we should classify something as covalent? And even from there, we can actually subdivide covalent bonds. So we can actually talk about two different types of covalent bonds, and one of these is a polar covalent bond, and the other is going to be a nonpolar covalent bond. So both of these are, covalent, in that they're sharing their electrons. The only difference between the two is that for the nonpolar covalent, the sharing is a little bit more equal. And when we go from the nonpolar covalent to the polar covalent, the sharing is a little bit less equal. The sharing is more towards chlorine almost stealing electrons from hydrogen, but not quite. This bonding is actually kind of a continuum, where nothing is ever purely ionic or purely covalent, but you have somewhere in between almost all the time. Okay, so how can you actually tell the difference? Well, one really useful scale to try to quantify this difference is called the Pauling electronegativity scale, where we actually can give numerical values for atoms. And so basically what these numbers are telling you is the higher the number, the higher the electronegativity of that atom. The lower the number, the lower the electronegativity of that atom. And just to go over electronegativity just for a second, electronegativity, you basically, when you hear the word electronegativity, you should think about just how able an atom is at pulling electrons toward itself. We would then say that chlorine is very good at pulling electrons towards itself, and sodium is very poor at pulling electrons toward itself. Okay, and let's just go ahead and throw in some other numbers to see how these polar covalent and nonpolar covalent modes of bonding fall when on the Pauling electronegativity scale. So what you see is a very big gap between the sodium and the chlorine, which then results in something that looks a little bit more ionic. And as you close that gap for the polar covalent, this gap is a little bit smaller, and so it's a little bit less ionic, and it looks a little bit more like we're actually sharing electrons between these two atoms. And then as we go to nonpolar covalent, this guy, this relationship, there's a very little difference between the hydrogen and the carbon. And so, because they have similar electronegativities, they both have about the same amount of pull. And because of that reason, this is a little bit more of a sharing interaction and less of a stealing interaction. So I like drawing trends whenever we can. So instead of just memorizing the numbers for the Pauling electronegativity scale, there would be a lot of these numbers to memorize. We can always reference a periodic table. So if you look at this table, a trend to draw is that as you go from left to right on the periodic table, electronegativity goes up. And another trend is that as you go from low to high on the periodic table, electronegativity also goes up. Okay, and from there you can even draw an even more generalized trend, which is as you go diagonally on the periodic table, as a whole, there are exceptions, but electronegativity also goes up as you go diagonally from the bottom left diagonally to the top right. So, let's just say you totally forgot the Pauling number for sodium or chlorine. What you can do is you can always just reference a periodic table and say, oh, sodium's right here, and that's sodium, and then try to find chlorine. Chlorine's, right over here. And so then if you were to travel from left to right, it's no surprise that, sodium is a little bit less electronegative than the chlorine. Overall, you could say which atom is more electronegative. And the bigger the gap, in general, the higher the electronegativity difference. Okay, so again, there are exceptions, but the trend pretty much holds as you go down the table.